relatively speaking, we're not so much a dangerous dose of radiation. Believe me, here we're exposed to radiation. It's quite scary. So yes, you can be exposed to radiation, but ionizing radiation, which usually tends to be quite rare. Unless, of course, you'll be anyone here from Cornwall. No? Okay, good. So we're quite happy to work. So Cornwall, of course, you get a lot of radon gas coming out of the rock and actually accumulating in cellars. So you see a high rate of certain types of cancers in Cornwall, particularly for those who spend a lot of time downstairs rooms or have cellars that are exposed to breathing in that radon gas. What else? The sun. So ultraviolet light, particularly if you're light skinned, is a radiation source that can cause gene toxic damage. Any of you who smokers? Smokers here? Let's get a bit to that too. So smokers, anyone here drink? Drink time? So, you're very clean with these people. Let's try the next one. Barbecues? Anyone go to barbecues? One person, two people. You guys are below risk then. It's a classic example of putting lots and lots of mutagens into one place. So if you go to a party on a hot sunny day, you get sunburned, you smoke, you drink, and you eat barbecue, particularly meat, which you burn, produce nitrosamines, you're at high risk of getting cancer. Every single one of those elements has a potential for generating gene toxic stress. And the particularly bad ones is the combination of alcohol and smoking and nitrosamines actually means that you increase your risk substantially of actually getting esophageal cancer or colorectal cancer. Something to think about. So we expose ourselves to these types of mutagens all the time. We have lots of evidence of these types of risks. Okay, transition. So I mentioned skin before, gave you a kind of model or an idea of what's going on. So here's this is not a real thing, it's a cartoon. Essentially what we're trying to illustrate here is here's our basal lamina, or basal membrane, the underlying lamina propria. So this, for example, could be the single cell layer of the mucosa of the gut. It has typical organizing structure. In normal cases, you have lots and lots of cells, and depending on where you are, if you have a colonic crypt, for example, you know how much you remember from what you did in anatomy and physiology. I'll ask you actually, in the colon, each of those glands that produce mucus, where are the binding cells? Remember it's left. It's the cells that bind all the time. Where are the cells that bind in the colon? Are they found throughout the whole? So you mentioned this. Great. So basically the crypt, the bottom part, is where the stem cell niche resides. And that's where all cell division occurs. Those